Alright guys, welcome back. We're looking at chapter 8.7. Once again, here's vocabulary that's going to facilitate your learning. If you have been paying attention, it's identical to what has been on here before. Okay, so you might not even have to look them up if they're already in your notebooks. Alright, the most important part of this material is going to be this screen here. Okay, it's loaded with all the information you're going to need for this section. Okay, some might call it a cheat sheet, but it's got a negative feel to it. Okay, this is more of a master sheet. Everything you need to know is on here. Right? So just so there's no confusion, I'm going to rewrite it to clarify some things. Okay, this looks like an index. It is not. Okay, it's a coefficient. Right. The index could be invisible, but I'm going to write it here as a 2. Right. A's got some properties. Then we'll have 1 over B itself's got these properties. Right. This is something like what we've called in the past a skeleton, okay, or standard form. Notice I have an x minus. Right. Now I close the radical because out here is going to be k. Right. What I'm going to do here is I'm going to add parentheses around k because it comes after the plus. I'll put parentheses around h because it comes after the minus. Alright. I'm going to read a little bit about this with you guys. One thing I'm going to add here before I forget, okay, because we're going to be using a lot of this lingo, I'm going to introduce some symbols that will help us skip a lot of this writing. Okay. So let's take a look at A. What does A tell us? This coefficient up front. Okay, it'll describe a vertical stretch or compression. When A is less than 0, there's a reflection across the A axis. Alright. So I'm gonna see if I can match colors here. So that's in red. So for this one, we're gonna use this symbol. Okay. Up and down, since it's a vertical stretch or compression, and when we need to refer to a reflection across the y-axis, we'll simply introduce an R with an X subscript. Okay. All right. The next one we'll talk about is B. Okay, I'll simply go black on that one. And this one, the absolute value of B, right? Disregard plus or minus. Will describe a horizontal stretch or compression factor. So okay, this one, we'll use this symbol for horizontal stretch or compression. And when B is what? Negative, there's a reflection across the y-axis, so we'll simply use an R subscript Y. Alright? So again, this is a very important screen, so take time here, pause the video, really get this stuff down. Next we'll go blue. Alright. H simply describes a horizontal translation. So since it's horizontal, it's either going to shift to the right. Notice the arrows only either point right or they'll go left, not both ways. And that's pretty much it. And in green, okay, we have K, which is a vertical translation. So you probably guessed it. It'll either be right up or down. Okay, whatever units. Excuse me, the use of these types of symbols will be for the stretches or compressions. Okay, and this is for shifts vertically or horizontally vertically. Okay. Alright, so with that master material on hand, let's go ahead and apply it here. Okay, this one says graph. So we've got a graphing utility. Let's go and use it. Identify domain and range. So that's going to be important. Alright. So let's go into the calculator. So it's 3 cube root of x plus 6. 3. Look at this feature here. Okay, look at this one in particular. 3. It allows me to choose the index. We hadn't discussed that earlier, but now you know. And we have x plus 6. Okay. X plus 6. Now, by the way, this one's not directly related with the notes you just looked at. Why? Because The one we looked at had an index of 2. This one's an index of 3. Okay, so make sure you've got your information well organized. Okay, so there's the graph. Okay, what do we got? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. About right in the middle. Okay, so what I'm going to do here, since I can, I'm going to cheat here. I'm just going to take an image of this. Alright, so once a graph, there it is, done and done. It does want me to identify domain and range, which should be very easy to do. Okay, the domain is the set of all x such that what? Okay, as you can see, this good thing goes to the right forever, to the left forever, and if you're not a believer, you can always play with the calculator. So there's no restrictions, so x is an element of all reals. Okay? No restriction. The range, you guys know, is the set of all y's such that y. Okay, if you look at this, right? Again, you can play with the calculator, but upon further investigation, you'll see that it goes up forever, down forever, which is always nice. No restrictions, same thing. Okay, it's free to be anybody and everybody real number. All right, next, using the graph of f of x as a guide, describe the transformation in graph g of x. All right. So again, when you're looking at square root of x, that's the parent function. So let's go ahead and kind of describe f of x in an expanded form. Okay, what I mean by that is that master sheet, it should have all those ingredients. So if it needs a coefficient, apparently a 1 would apply. There's no index, but it's assumed to be a 2. Okay, in here I should have 1 over b, but since there's nothing there, it's implied to be a 1, so I can have 1 over 1, so b is 1. X, right, let's go back and take a look at the master sheet. Okay, when that comes next are parentheses x minus. So x minus, I don't have any value there, so if I subtract 0, I haven't changed anything. And out here, I should have a k, I don't have anything, so if I add a 0. Okay, so once again, this is equal to this in that standard form. Okay, so that you have a, b, h, and k. Alright, although that was not necessary, I think it'll help some of you guys really make a match between an actual problem and the notes themselves. Okay. Alright, so anyways, so here's the parent function. Describe the transformation when you basically introduce a 3 on here. Okay. So let's see here. So g of x has a 1 up here front, the square root of. Notice this one is, okay, there's a 3 in there. Okay. 3. There's nothing here, and out here there's nothing. Okay. So really our focus is in here. So where I have the 3, that's the 1 over b portion. Okay. So everything else is standard, so I don't have to say anything. Right? When they say describe the transformation, basically identify what is different than the parent and discuss it. Alright? So one thing you can do here, okay, there's different ways to approach it, is I'll do it the method that's maybe more comfortable is, right, to cancel out b here, I'll multiply by b, so I'm looking for 3b equals 1, and to solve for b, I can divide by 3, and I'd be left with b equals 1/3, right? So now that I know what b is, okay, based on the master sheet, let's take a look at what b does. Okay, it describes a horizontal stretch or compression. And so that you don't overcomplicate things or your lives, we'll introduce a symbol, right? Horizontal stretch or compression, and we'll put in parentheses by a factor of 1/3. Right? Again, these are our symbols. Make sure you understand what it means. Horizontal stretch or compression by a factor of 1/3. Next, use the graph of f of x as a guide to describe the transformation. So you know how to expand this one. Okay, so now what I'm going to do here, right, I'll do here real quick once again to encourage practice. 1 over 1 x minus 0 plus 0. Okay, standard form. How does g of x compare? Okay. Well, I already noticed there's a difference there. That's the same. Okay, this guy's the same, so b is not going to be a concern. I do notice that I have an x minus 3, so that will have to be addressed, and out here there's nothing. Okay. Alright, so this first difference, let's go back to our master sheet, and it describes a vertical stretch or compression. Okay, it's not negative. Okay, so that's the first thing I'm going to say is there's a vertical stretch or compression by a factor of 4. What else is on here? Okay, this guy in here is h. What does h do? H is a horizontal translation. Okay. Alright. Now it comes after the minus, so it's going to be, if this is horizontal, right, and in parentheses is h, it's a positive 3, so I would assume it goes right. Okay, 3 units. Alright, that's it. Everybody else is standard. Alright, moving on. The parent function f of x is stretched horizontally by a factor of 4, reflected and translated left 2 units, right the square root function g. So now we have to compose. Right? So once again, just as a good habit, I'll expand the parent function. 1 over 1, x minus 0, plus 0. Okay. What they want me to do is to produce a g of x, okay, that basically transforms f. So let's go ahead and kind of leave some blanks there, right? So 1 over something there, x minus something there, plus something. Okay. So what I'm looking for, this one says stretch horizontally by a factor of 4. Okay. So I'm not going to go back to the master sheet. You guys can look at your notes. Okay, so I don't eat up time here, but it's really as simple as plugging in a 4 there, because it is talking about a horizontal stretch. So done. Right? Now it says reflected across the y-axis. If you look at the master sheet, that's when this b here is negative. So I've got him taken care of, and translated left 2 units. Alright, pay attention here. If I just put in a 2, it's positive 2, so that's to the right. To make it left, I'd put in a negative. Alright, of course I can rewrite it with a plus, and I'll do so in a little bit, but I have completed all translations. Since this one wasn't addressed, we'll fill it in with a 0. Neither was this one, we'll put in a 1. And now I'll clean up the version, and it should look something like this. Okay, he's unnecessary, and so is he. And this is very necessary, so I'll put 1 over negative 4. Okay, this will become x plus 2, and plus 0 is unnecessary, so this is what it looks like at the very end. Alright, let's go ahead and take a look at the last one. Alright. And I spoke how to turn out. This is the second to last one. Okay, but this one's straightforward. It says graph the inequality. So let's go to our graphing utility. See if I can memorize that. X is less than or equal to the square root of x minus 5. Okay. Let's see here. I'm gonna hit delete here. Introduce what? Less than or equal to the square root of, darn it, x minus 5, yeah. X minus 5, I'll hit enter. Okay, this one's got a unique look, but it is exactly as is. Okay, the details of which we can discuss in class. So let me go ahead and capture this image here. 1 second. Alright, let me go ahead and kind of minimize this image here. Okay. Now you do want to take some time and toy with this on your calculators, but all that happened here is essentially the graph of the square root of x minus 5 is this. Okay. It's been shifted, what, 5 units to the right, and why is it shaded to the bottom? Because it's all the y's underneath or equal to. Okay. If it was not equal to, remember, it would be that dashed line like that. Let me see if I got a favorite line here. Right. If it was not equal to, since it is equal to, you can keep it a solid line. All right. So graphing ones are always quick and easy. All right. Let's see if we can move on to the last one. Okay, that is the last one. Let me double check that. Alright guys, going ahead and found the last one officially here. The function g is a translation 3 units left and 2 units up of f equals such and such, right? Okay, so all that's happening here is that you no longer are working from the parent. You've got some derivative of it, okay? And from there you're further transforming it. So it's like they took the parent, transformed it, and now we're adding additional transformations. Okay, so let's go ahead and now this one I'm not gonna expand it, I'm gonna approach it in a simpler fashion. Alright. So here's what they're saying is they're working off of f to create g. How do they do that? Okay, so they need to translate 3 units left. So, right, I'm going to come in here, x. Okay, it's already got a plus 9, so I'm not going to mess with that. However, so I'm going to translate it 3 units left. How do I do that? Well, I need an x minus, that's standard. But if I put a 3, that'll go right, so I'm going to put in a negative 3. Alright? Then they also want me to shift it 2 units up. So that occurs out here, so plus 2. And now I'll simply clean up the math. And I've got the square root of, right? This is x plus 3 plus 9 plus 2. Alright, so now let's go and further clean this up. As you guys can see here, okay, this doesn't distribute, if you were thinking that because of the plus. So essentially we have x plus 12 underneath the radical, and out here we have plus 2. Done and done, guys. We hit 17-minute mark, almost 18. Thanks for your time. Take good notes, and we'll answer questions and comments tomorrow. See you.